Hey everybody, and welcome to another lecture. And in this lecture, we're going to be going over the SQL database introduction. This brings us to our first question. What is a database? A database is an organized collection of structured information of data which is stored in a computer system. The data within a database can be easily accessed. The data can be modified. The data can be controlled and organized. Many databases use a structured query language, SQL, to modify and write data. What we can really take away here is that a database is nothing without data. A database is more or less structured data, so that brings us to our next question. What is data? So what is data? Well, data can be related to just about any object. For example, a user on an application may have a name, an age, email, gender, or even a password. All of this can be considered data. The user in this example is an object, and this object is made up of data. Think of a user on your favorite social media platform. This user may have a username, a profile picture, may even have some posts, images, and other objects of data, or other users may be able to look at. Programming is all about how to handle data. So let's rewind a little bit and go back to how do we handle data? A database is how we handle data. And a database, again, is a collection of data. And since data on its own is just data, a database allows the management to this data. Databases are organized in how data can be retrieved, stored, and modified. There are many types of database management systems, also known as a RDBMS, which handles the database we are creating. And we'll cover this in just a few slides. But first, let's check out what a database looks like in physical form. So let's look at some databases before we go into computing. Before we continue thinking electronically, let's think of a database in a physical form. One example of this would be a dictionary, while the other may be a phone book. Now, a dictionary has a word and definition relationship. For example, you open a physical dictionary to try and find a word in which you want the definition for. For example, you may open up a dictionary to look up the definition of computer. As you open the dictionary, all words will be listed in alphabetical order, and when you find computer, it will say an electronic device for storing and processing data, typically in binary form according to instructions given to it in a variable program. Another example of a physical database is a phone book. A phone book has a name and phone number relationship. So in this example, we have an example user who has a phone number of 123-456-789, example user 2 who has 123-765-4321, and lastly a user 3 which also has a phone number. Again, we are seeing here is the idea of a piece of data having additional data. Each word or example user has a definition or phone number attached. After we have all this data in a relational database, how do we access this? Well, the way we can access this is using something called SQL or SQL. What is SQL? Well, like I mentioned already, it can be pronounced either as SQL or SQL. SQL is a standard language for dealing with relational databases. SQL can be used to search, update, add, and delete database records. This information may sound very familiar, and that's because SQL in essence is using CRUD operations to a database. Again, to access a database, we need a RDBMS to handle pretty much everything involved with the database. What are some of the top SQL database management systems on the market today? We have MySQL, which is a RDBMS that is extremely popular. We have PostgreSQL, is another database that you really cannot go wrong with in a production environment. And lastly, we have SQLite. And SQLite is the most popular development database management system. During our development, we will use mostly SQLite, and that is because it is very lightweight and works right in our application. In a future section called Production Databases, we will go over the installation and setup of both MySQL and PostgreSQL. Awesome. Well, this wraps up this lecture, and I will see you in the next video.
In this lecture, we're going to be installing SQL Alchemy to our application using pip, and then we're going to create a new folder and directory for our to-do application, and then we're going to create a database file where we're connecting to our SQLite database. We're going to be creating an engine for SQL Alchemy, creating our session maker, and then finally creating a base that will allow us to create database models as we inherit the class. Let's start by installing SQL Alchemy to our application. We can do this by typing in pip install SQL Alchemy. Now that I have SQL Alchemy installed, I'm going to close my terminal, and within my parent fast API directory, I'm going to create a new directory called to-do application, called to-do app. Now within to-do app, I'm going to create a new file called database.py. And now that we have database.py within our to-do directory, we need to connect to a SQLite database. We can do this by typing in a new variable, SQL Alchemy underscore database underscore URL equals a new string of SQLite colon / dot / todos.db. Now the todos.db means there will be a new DB file created within the directory that's called todos.db, which is going to store all of our data for this application. And now our first step is to create the SQL Alchemy engine. This engine will be used in other areas of our application. To first be able to create an engine, we need to import our SQL Alchemy create engine. So from SQL Alchemy, import create engine. Now under our SQL Alchemy database URL string, let's now create the engine. We can do this by typing in engine equals create engine, and then as the parameters, we're going to pass in our SQL Alchemy database URL, and then we need to pass in some connect arguments. Which is check same thread, which is going to be false. We now need to create a session local class. The session local instance will be a database session. To create a new database session, we must use the session maker function. So therefore, we need to import session maker. So right under SQL Alchemy, create engine, let's import from SQLAlchemy.orm, import session maker. And now right under the engine, let's create a new variable of session local, which is equal to session maker. And as the parameters, we're going to say auto commit is equal to false, auto flush is equal to false, and bind is equal to engine. And now lastly, we need to create base. Base will allow us to create each database model. So we will inherit the base class in future files. But to be able to create a base, we need to import declarative base. We can import declarative base from SQLalchemy.ext.declarative import declarative base. And now right under session local, we'll say base equals declarative base. Alright, so to review, we imported create engine, session maker, and declarative base. We then connected to a SQLite database using our SQL Alchemy database URL, and we're going to be creating a new file called todos.db, which is actually going to be storing our database. We then created an engine by saying create engine SQL Alchemy database URL, and then we're passing in the connect arguments of check same thread and false. Those connect arguments are just relative to SQLite and may not be needed in different types of databases. We then created a session local class, which is going to be an instance of a database session. And then finally, we created base, which is going to create the database model, which we will have to inherit in the future videos. This wraps up everything about installing SQLite and starting our database journey. I will see you in the next video. And in this lecture, we're going to be creating our models.py file. Our models.py file is actually creating the table and column structure of what our database is going to look like. Let's start by creating a models file inside our to-do parent folder. And inside models, we're going to have to import some SQL Alchemy things. The first thing we're going to need to import is Boolean. We're then going to need to import column, integer, and string. We can do this by saying from SQL Alchemy, import Boolean, comma column, comma integer, and comma string. And now we also want to say from our database file, we want to import base. So if we remember in our database file, we have this base that we're going to be using in other files. So we're going to want to go back to our models and also import base. And now let's create our table. So our table is going to be our to-dos table. We can create a table within the SQLite database by just defining a class of to-dos, which extends base. So let's start by saying class to-dos base as the parameter. And inside to-dos, we want to do underscore underscore table name underscore underscore, which equals to-dos. This is where we define the actual table name. And now we want to define the columns within the table. So we're going to need an ID, which is going to be the primary key for the to-do. We're going to want a title, a description, a priority, and if the to-do is complete. So I'm going to start by saying ID equals column, and then inside the column, we're going to say this specific ID is going to be an integer, and the primary key is true, and the index is true. Title is going to equal column, but we're only going to say this title column is going to be a string. Description is going to equal column, which is of a string. Priority is going to equal column, which is an integer. Complete is going to be a column, which is of type Boolean. And here we're going to define the default value for complete, which is going to be false. So when a new to-do is created, it's automatically going to be false, which means it's not complete. So to recap this, we created a new class of to-dos, which extends base from our database. We defined table name, which name is going to be to-dos. We have an ID, which is a new column in the database, which is going to be an integer in the primary key. We have a new title, which is going to be a column in the database that's of string. Description, which is going to be a column of string. Priority, which is going to be a column of integer. And if the to-do is complete or not, which is going to be a Boolean. And every time a new to-do gets created, the default value for complete is going to be equal to false. This wraps up the lecture on us creating our models.py file, and I will see you in the next video. In this lecture, we're going to create our main.py file, which is going to be the main file for our to-do app where we're going to create all the APIs. Within the main.py file, where we can instantiate the base, which is going to create all of the tables and columns for our application. So let's start by right-clicking on our to-do app and creating our new Python file of main. And inside main, we're going to have to do all of our normal imports to make sure our application is rendering. So we're going to say from fast API, import fast API. We're also going to want to import our models, which is our table and our columns. And lastly, we're going to want to say from database, import our new engine. Let's now say app is equal to fast API. And right under app equals fast API, let's say models.base.metadata.create all. And as the parameter, we're going to say bind is equal to engine. And right under this, I'm just going to create an API for fun with a decorator of app.get. And then I'm going to create a function async def create database. And I'm just going to return a string saying database is created. Let's now open up our terminal and let's jump into our to-do app folder. And then once in to-do app, let's now say unicorn main:app -- reload. And now we have our application running. And after a few seconds, we can see that todos.db was added within our to-do app directory automatically. That's because when we ran this application, this kicked in, which created our todos.db tables and columns. Let's go investigate the todos.db in the next lecture, and I will see you in the next video. In this lecture, I'm going to show you how to install SQLite 3 on a Windows operating system so you can manipulate the data of a database, be able to select all from a database, and be able to just completely be able to use a SQLite database from your terminal. To be able to do this, the first thing you need to do is go to Google and type in SQLite 3. From here, you're going to want to go to https://www.sqlite.org. If you want to skip the entire first step, you can just go to this URL, which is sqlite.org/index.html. From the home page, we're going to want to click download. And when you're in the download page, you're going to want to scroll down until you see the pre-compiled binaries for Windows. And you're going to want to click the very last one, which is the SQLite Tools Win32 x86. You want to click this one because this comes with a lot of stuff. It comes with the entire bundle for command line tools for managing SQLite database files. That's like one of the biggest things you want. So let's download this by clicking on the link. And now once you download it, let's open up our downloads file. And I'm going to extract this. So we're going to need to extract this file that we just downloaded because it came as a zip. And I'm just going to extract it right here in the downloads file. And now the file that we just downloaded should come with 3 files within. We're going to want to copy this or cut it. And we want to hop on over to our PC and then go into our C drive. And within our C drive, let's just paste it in here. We're then going to want to rename this to SQLite 3. And now we have the SQLite 3 file on our C drive. We're just going to want to open this up and grab this path. From here, we're going to want to open up our Systems Environment Properties. You can accomplish this by pressing the Windows button and then typing in ENV for Environmental Properties. From here, let's click the Environment Variables. And inside our System Variables, we want to modify Path. Inside Path, let's say a new environment variable, and let's just paste in our C drive SQLite 3 path. And press OK. And then let's press OK again. And then one more OK. From here, we should be able to open up our command prompt and say SQLite 3. If everything looks correct, you should now get a version of SQLite 3 printed back to you. This wraps up the lecture on how to download and install SQLite 3 on your Windows machine and set up your environment variables. And I will see you in the next video. And in this lecture, I'm going to show you how to install SQLite on a macOS so we can use the terminal to manipulate the database and tables and columns and all the fun stuff that comes with databases. The first thing we're going to do is install Homebrew. So in my Google search, I'm going to type in Homebrew. And I'm going to go to https://brew.sh. And then from here, I'm going to copy this command. And from here, I'm going to open up my terminal. I'm going to paste in that command and press enter. Here it's going to say you need to type in your password. So I'll type in my password. It'll tell you what scripts are about to be installed. Press the return button to continue. And it's going to download and install Homebrew. Let's now close out of the terminal and let's reopen the terminal. And now you have Homebrew installed on your machine. Now SQLite 3 should come pre-installed on Homebrew. So if we type in brew list, we can see that we now have SQLite. If for some reason SQLite 3 is not installed, we can install SQLite by typing in brew install SQLite. When you press enter, it'll install all the dependencies for SQLite. And since I have it installed, let's just use SQLite. We can now run SQLite by typing in SQLite 3. And immediately we can see that we get the version returned to us. We can close SQLite by saying .quit. This wraps up the video on how to install SQLite 3 on a MacBook, and I will see you in the next video. And in this lecture, we're going to be going over basic SQL queries. All right, let's start by going over inserting data into a database table. Imagine our to-do database table. A single to-do record within our database looks very similar to this. Our to-do will contain an ID, which is our primary key to identify each record, a title for the title of our to-do, a description that describes the to-do and gives it a little bit more information, priority, which is the ranking of how important it is to accomplish this to-do, and a complete column, which displays if the to-do is complete or not. And eventually we'll be adding a foreign key of owner, which connects this to-do to a specific individual or user. So in SQL terms, how do we add data to a to-do? To start, we need to say which fields of the record we want to add to. We can see the SQL command that says insert into to-dos, so insert into the to-dos table a title, a description, priority, and complete. We can see we are not saying ID, and that's because we want the database to handle this automatically for us and to auto increment so we can't accidentally assign the same primary key to two different to-do records. We then want to type values, which is go to store, to pick up eggs, for as a priority, and false for complete. When we run this, we will be able to see that we are creating a new record in the database. Our title, description, priority, and complete all get updated based on this command, and we now have our database configured to auto-increment the ID on its own. This way we never have to worry about updating the ID ourselves, and we can trust the database to do this for us. Alright, now that we've created one record in our database, let's create another record. We'll be inserting into our to-dos a title, description, priority, and complete. And we'll say the values of these are haircut, need to get length of 1 millimeter, 3 priority, and false for complete. Once we submit this to the database, we can see that we now have two records in our database, one with an ID of 1 and one with an ID of 2. Alright, now that we just went over inserting into our database, let's keep adding to it. Now, I'm just going to pretend we are inserting this data, so let's move on to a new record where we just created a feed the dog as a title. As a description, we are going to be using make sure to use the new food brand with a priority of 5 because we need to feed our dog and not complete. And then let's add another one about watering our plant as a title. Description is inside and outside plants with a priority of 4 and also not complete. Let's add a fifth record of learn something new, learn to program, 5 and also not complete. And lastly, let's pretend we added a sixth record, which the title is shower. And the description is you have not showered in a few days, so it's probably a good idea to take a shower. A priority of 5 because you smell really bad, and complete is false. All right, well, we now have some data in our database. We now want to be able to withdraw data from our database. So how can we do that? To be able to start, we need to use the select attribute. We can say select asterisk from to-dos. Now in SQL, an asterisk means all columns and rows. So with this example, we are saying select all rows and all columns from our to-dos table, which in reality would just give us everything in that table. So all 6 records we currently have saved in our database will be displayed on the screen. What if we modified our select script just a little bit to only retrieve the titles of our records? We can accomplish this by saying select title from to-dos. By doing this, we are selecting just the title from our to-dos columns. Our response from the database will look very similar to this. We get go to the store, haircut, feed dog, water plant, learn something new, and to shower, with no other information. And that is because we are specifically said we only want the titles from the table to-dos. What if we modified our select script even a little bit more to retrieve the description of all the records? Well, this will be very similar to how we handled the title portion of our select command. We can accomplish this by saying select description from to-dos. By doing this, we are selecting just the description from all the to-do columns. Our response from the database would look very similar to this. We will get to pick up eggs, need to get length 1 millimeter, make sure to use new food brand, inside and outside plants, learn to program, and you have not showered in a few days. Well, being able to get only one column may be great in theory, but in our case, it doesn't actually do much. If we get a title, we want the description as well, and vice versa. Let's go ahead and modify our SQL command a little bit. Now let's type select title, comma, description from to-dos. This will properly select all titles and descriptions from our table, which will give us the titles and descriptions that we are seeking. And there it is, great job. We get the title and description from our to-dos table. Let's keep this going and add another column to our select command. This time we are going to be adding priority along with our title and description. We can accomplish this by saying select title, description, priority from to-dos. This will retrieve all titles, descriptions, and priorities from our columns. And now we will be able to see our titles, descriptions, and how important each task is. Now that we covered the select command from SQL, let's keep this learning up and learn about the where clause. The where clause specifies criteria that a field value must meet for the records that contains the values to be included in the query results. Let's check this out. Okay, remember when we wrote select asterisk from to-dos and we returned all rows and columns from the table to-dos? This time, we will be writing the same thing. However, we'll be adding a where clause where the priority of the record must be equal to 5. This means we are selecting all rows and columns where a priority is equal to 5. Therefore, when we run the SQL statement, we will get only 3 of our 6 records returned. This is because only 3 of the records have a priority of 5. But we'll be getting all columns of each of these records. Let's try another SQL statement with a where clause. This time, let's write select all from to-dos where title is equal to feed dog. So this means we are saying let's select all rows and columns where title is equal to feed dog. Well, based on our table, we only have one record where title is equal to feed dog. Therefore, if we run this execution, and we will get only one record back, which is feed dog as the title. Okay, now the main use case for using the where clause is when trying to identify a record by ID. We can pretend that our API passed an ID and we want to return that specific ID and record. Well, if we are in the database, we can say select from to-dos where ID is equal to 2. And to put this in plain English, this is saying select all rows and columns where ID is equal to 2. And this time when we run the script, we will get our single to-do record, which has an ID, our primary key, that is equal to 2. Let's now move into the update clause. The update clause is used when we want to update a record in the database. Now to update a record, we will have to use a few different attributes. We will have to say update to-dos, set complete equal to true, where ID is equal to 5. So in theory, this is saying update all rows and columns to now have complete be equal to true, where a record has an ID that is equal to 5. Therefore, the record with the ID of 5 will change the complete column to true. This can be kind of confusing at first, but the more you work with it, the more sense it starts to become. We are saying we are making an update to the to-dos table, and then setting a column field to a new value, and then just locating the record we want to update to make the update true. Now in the last slide, we used an ID to identify which record to update. This is by far the most practical and best way to update a record, is to always locate the record by the primary key, because the primary key is going to be unique. However, it is possible to push an update when not talking about the ID. For example, we could say update to-dos, set complete to equal to true, where title is equal to learn something new. This will essentially update all rows and columns to now have complete equal to true, where title is equal to learn something new. This will work and modify the record where the title is learn something new. However, the issue with this approach is that there could be more than one title that says learn something new, and that means nothing is unique. So if you want to use this approach, always remember that, the title is not a unique name. Therefore, we could be changing multiple records to true. All right, and now for the final clause for this basic SQL intro is the delete clause. This clause is used to delete a record from a database. Again, the best way of deleting a single record is by the primary key, which in this case is the ID. We can say delete from to-dos, where ID is equal to 5. This statement says to delete all rows and columns, where ID is equal to 5. Therefore, after this statement gets executed, we will be left with a table of 5 records. However, the record with the ID of 5 is completely deleted. Now, in many applications, if you do not want to completely remove a to-do, so a user has a history of to-dos, the application will create a table that holds quote-unquote deleted records. This way, things are not permanently erased, but just removed from the table of the main application, and moved to another table where the table still exists. And as always, you do not have to delete based on ID or a primary key, even though it is significantly more safe. We could write delete from to-dos where complete is equal to 0. This will delete all rows and columns where complete is equal to 0. So if we did not change any of our complete areas to true, we would essentially erase and delete our entire database. This is the risk in using the delete functionality when not using it by a primary key to delete a specific record. Alright, now I know we went over a bunch of SQL commands and the most popular commands when dealing with CRUD operations in case you want to manipulate the data yourself. Luckily for us, SQL Alchemy handles a lot of these commands on the application side, so we don't have to worry about writing the commands ourselves to manipulate the data. Alright, well cheers friends, and this wraps up this video, and I will see you in the next lecture. In this lecture, I'm going to show you how to manipulate our SQLite 3 database using our terminal after successfully installing SQLite 3 onto your machine. So once we're in our project, let's open up our terminal. And the first thing we need to do is cd over into our to-do app. Once you're in your to-do app, let's type in SQLite 3, and then let's type in todos.db. And todos.db is going to be mimicking the database that you created within the folder. So immediately we get our SQLite version, and it's telling us to tap in enter if we want to help I'm going to scroll our terminal all the way to make it full screen so we can see more. The first thing I'm going to do is type in .schema. This will show you all the tables that are currently within our SQLite 3 database. We can see that we have a table of to-dos that have an ID, a title, a description, a priority, and complete. And then it's telling us our primary key is our ID. So let's insert a record into our to-do table. We can accomplish this by typing in insert into to-dos, and then within parentheses, typing in title, description, priority, and complete. And then making the values go to the store, pick up eggs, five, and false. And here it's telling me I forgot a semicolon. So you can just type in semicolon if you ever get these dots and arrows. And now let's type in select all from to-dos. However, all is going to be a star, so select star from to-dos. And don't forget that semicolon. Here we can see that we have go to the store, pick up eggs, 5, 0, 0 means false, 1 means true. And then our ID is getting automatically created because we have integer not null. So it's automatically going to increment up so we have a primary key for each element within our table. I'm going to press up on our right arrow pad, and I'm going to press up one more time and then one last time until we get insert into to-dos again. Here I'm going to just modify this list so we can add another to-do to our table. Instead of go to the store, I'm going to say cut the lawn. For the description, I'm going to say grass is getting long. I'm going to make this priority a 3, and then also false. However, I'm going to add a semicolon at the end. Now if we say select all from to-dos, we will get 2 elements returned. We get 2 elements, go to the store, pick up eggs, and we also get cut the lawn, grass is getting long, and the IDs are 1 and 2. I'm going to create one more element. I'm going to say feed the dog. He is getting hungry. I'm going to make this a 5 and also false. And one last time, I'm going to say select all from to-dos, where we now get 3 elements. Now, if you're like me, you don't like the view of how this comes in automatically and by default for SQLite 3. You can change the mode by typing in .mode and then typing in what type of mode you like at the end. A few examples are column. And now if we say select all from to-dos, we're going to get a nice little column list with ID, title, description, priority, and complete. You can do mode markdown. And if we type select all from to-dos, we are now going to get a new list of the same elements. You can do .mode box. which is going to make it a sealed box as the return. Or you can do my favorite, which is table, which is very similar to the box, but with dashed lines. Now I'm going to create one more element. I'm going to click up until I see our last insert. And here I'm going to type in test element. And I'm going to press enter. If we now say select all from to-dos, we now get a table view of our elements. And now let's say we want to delete test element. We need to say delete an element from this to-dos table where the primary key of ID is equal to 4. And the reason we're using the primary key is because the primary key is the only thing within this entire table that cannot be duplicated. To do this, we can say delete from to-dos where ID is equal to 4. If we now say select all from to-dos, we can see that the element was erased. Now let's go and create one more element. And here I'm going to say a new test element. Now if we say select all from to-dos, we can see that it reused the primary key that we deleted. So as for an example, it doesn't just skip 4 and then go to 5, it reuses some of the elements. And now I'm going to delete this last element. So delete from to-dos where ID is equal to 4. We got my semicolon, and then select all from to-dos. And now we have our starting elements for our new to-dos application. This wraps up SQLite, and I will see you in the next video.